This is section 2.3, finding real zeros of polynomial functions. And the first thing we're going to look at is polynomial long division. We're going to take this quadratic and divide it by this linear expression. When you divide by something, that goes on the outside of the division sign, and what we're dividing from goes on the inside. So this is how I would interpret that problem. And we always want to take care of the biggest term on the inside first. I'm going to put parentheses around this x plus 6 just to emphasize the fact that it is a binomial. There's two terms inside of there. And I'm going to ask myself, what do I multiply this x by to match up with the x squared that's in there? So x times x is x squared, so I'm going to put it above the division sign. It doesn't matter where I put it. I'd like to line them up so that the x goes above the 13x. So then x times x is x squared. X times 6 is 6x. And I didn't put any kind of sign in between the x squared and 6x because once I multiply these, then I'm going to subtract going down. So as soon as I draw the line, I'm going to write a subtraction sign. X squared minus x squared, they cancel each other out. That's great. That's what I wanted to have happen. 13x minus 6x is 7x. And then we're going to bring down the plus 40 at the end. So what's left under the division sign is smaller than the original. Go back to the same question as before. What do I have to multiply x by in order to get up to 7x? In that case, it's going to be a positive 7. 7 times x is 7x. 7 times 6 is 42. We subtract as we go down. So draw the line, subtraction sign, subtract those, they'll cancel out. 40 minus 42 is negative 2. And when do I know that I'm ready to stop? Well, I can't multiply x by anything in order to get negative 2. So this degree is less than what's out there. So I can go to my answer. It's going to be x plus 7 plus the remainder of negative 2 divided by, we're dividing by x plus 6. That's how we're going to write our remainders. We're going to write the remainder over what we're dividing by, and there's our answer. And that is polynomial long division. Got one more example of this one, and I threw this one in there because I just want to get a little more practice with this. Notice it is x cubed, x squared, x, and then numbered, which is good. There's no empty columns I need to account for. So I would stop the video and try this one. If you get stuck, you can watch the video, but give yourself a chance to work through this one. Meanwhile, I'll start. What do I multiply x by 3x cubed? That would be 3x squared. Multiply. And then draw the line, subtraction sign, those cancel out. 16x squared minus 12x squared. Bring down the next. What do I multiply x by to get 4x squared? That would be 4x. So 4x times x is 4x squared. 4x times 4 is 16x. Subtract. Those cancel out. Negative x minus 4. One more time. What do we multiply x by to get negative x? That would be negative 1. Negative 1 times x, negative x. Negative 1 times 4 is negative 4. Draw the line, subtraction sign. So I'm going to change the signs. Those cancel out. Those cancel out. There's no remainder. So our answer to this problem, without a remainder, is this. Instead of doing polynomial long division, sometimes synthetic division is a preferred way of simplifying. So let's go over this. If we take f of x divided by x plus 2, that means we're going to put negative 2 on the outside. X plus 2 is equivalent to a root of x equals negative 2. And then we're going to take all these coefficients. So there's 1x to the 4th. There's a blank here, which means there's 0x cubed, negative 10x squared, minus 2x plus 27. The process, bring down the first number, and whatever you get down here, you're going to multiply by what's on the outside and put it up on the next blank. So 1 times negative 2 is negative 2. Always add going down. Negative 2 times negative 2 is 4. Add down. Negative 2 times negative 6 is 12. Add going down. One more time. Negative 2 times 10 is negative 20. Add going down, and we get 7. Now, what does this mean as an answer? Well, if we took f of x, this whole big expression, and divided by x plus 2, we would get an answer of not 1x to the 4th anymore, but 1x to the 3rd. minus 2x squared minus 6x plus 10. And then the 7 is the remainder divided by x plus 2. So this represents the answer if we actually did the division. We can use synthetic division to check to see if something actually is a factor. And if we know it's a factor, it'll simplify whatever polynomial we had down a little bit. The other thing we can do with this synthetic division is what's called synthetic substitution. In other words, if I want to know f of 6, I could plug 6 in for all these x's and evaluate. Or using this process of synthetic substitution, I'm going to do what I did just a second ago. So we'll go through this 6, 6, 36, 26. 26 times 6 is getting pretty big. That's 1, 6, 1, 4, 154 times 6. 924. So when we add those together, we get a total of 951. So what that means to us is that f of 6 is equal to 951. 6 didn't go into it evenly. We didn't get a 0. So f of 6 is equal to 951. It's a quicker way to evaluate this. I never had to take 6 to the 4th or do negative 10 times 6 squared. I can use the synthetic substitution as an alternate way of evaluating the value of a function at a point. So synthetic is kind of nice to speed things up. And it's also going to help us as we go through the main topic in chapter 2, which is finding roots or zeros. Example, find all the roots given that x minus 4 is a factor. So if I said to factor this right away, I wouldn't know how to do that. Of all the methods I have with factoring, none of them would work. I could try grouping, it doesn't work. But since we're told that x minus 4 is a factor, that means 4 is a 0 of this. So using that to my advantage, I'm going to use synthetic division with those coefficients and see if I can simplify this down. One, 4, 3, 12, 2, 8, 16. Oh, wait, I did something wrong. Oh, very good. All right, so negative 8 goes there. Thank you. And that's going to make it a 0 at the end. So I should expect to get a 0 at the end. It means that there's no remainder. What was originally a cubic is now simplified down. This tells us that we have x squared plus 3x plus 2 with a remainder of 0. I don't know how to factor the original one, but I can factor this. The two numbers that multiply to 2 and 3 would be 2 and 1. So now all of the roots. Originally, I knew that 4 was a root because that was indirectly given to us as a factor. Now I know that negative 2 is also a root because of the way it all factored out. And then the final one is negative 1. Third degree, 3 roots. So synthetic division took a cubic, which I couldn't really do anything with, turned it into a quadratic that we could use. Another thing to add to our skill set is this rational roots test. And we can use this to figure out the possible rational roots. In the previous problem, we were told that x minus 4 was a factor, but if we weren't given that, could we have figured that out? Would we have known to look for 4 as a solution? So this is an idea that we can use to help us know what to look for. We look at the factors of the trailing constant at the very end divided by the factors of the leading coefficient. As an example, we have this equation, and we're asked with finding the possible rational zeros. What I'm going to do is make one big fraction and list all of the factors of 40, or of negative 40. So plus and minus 40, plus and minus 1, plus and minus 20, plus and minus 2. Those multiply to 40. The next one would be 10. Plus and minus 10 is plus or minus 4. Those multiply to 40. I'm running out of space in the middle. We could also have 5 and 8. So these are all of the factors that go into 40. Divided by all of the factors that go into 2. Well, thankfully, there aren't as many, so we can have plus or minus 1 or plus or minus 2. These are the possible ones. So maybe 40 divided by 1. Maybe 40 is a factor. It's a possibility. Or maybe negative 40 over 1 is a factor. That's, again, it's another possibility. Or maybe 5 over 2, or negative 5 over 2, or 1 over 2, negative 1 over 2. There's a lot of possibilities here. If I'm not giving any head start, these are ones that I could actually look at. There's a ton of them to choose from here. If I was to do this by trial and error, I probably wouldn't want to start with the bigger ones. I'd want to start with the smaller ones. Our goal here is to next find the actual zeros of this one. And to do this, we're going to use synthetic division. I'll start at the very bottom and choose a number that I think is small. And I think 1 would be a good first one to start with. We'll do 1 on the outside. And to see if it works, we're going to use that synthetic division again. 2x to the 4th minus 9x cubed minus 16x squared plus 90x minus 40. And it's a bit of trial and error at this point. I like using the computer for this because I can erase evenly. But as I start going through this one, if you're better with the synthetic division process, it can speed things up for you a little bit. And once you get near the end, once you realize, okay, wait a second, this one isn't going to work, you can erase it and say, all right, start over again. I know that in this case, 1 didn't work. Maybe negative 1 works. I'll try again. 2 times negative 1 is negative 2. Negative 5, positive 5, 95, and that's not going to work either. So neither 1 nor negative 1 is going to work. Still a little bit of trial and error to this. I don't exactly like having to do a lot of trial and error. So I'm going to jump ahead to, I don't know, the number 4. So bring down the 2. 4 times 2 is 8. Add those together, negative 1, negative 4, negative 20, negative 80. Add those together, that's 10. Multiply those, 40, 0, great. I guessed well. So 4 is one of the actual zeros. What we have left is no longer 2x to the 4th, it's 2x to the 3rd. So it's a smaller equation, but it's still a cubic, and I don't have a good way of solving those, so I'm going to have to do a little more guessing and checking to figure out what's going to go into it. Instead of using the top row of black numbers, I'm going to use this new row of blue numbers because, well, there's fewer of them, and it's going to be less work to check. Again, there's a lot of other ones I could do. I tried 1 and negative 1. I skipped over 2 and negative 2. There are some fractions. For instance, I could have 1 over 1, 1 over 2, and maybe one of those would work. So I'll go ahead and try 1/2. You'll get lucky and guess correctly. So bring down the 2. 1/2 times 2 is 1. Add those together, we get 0. Add that, negative 20. 1/2 times negative 20 is negative 10. Oh, lucky guess. 1/2 works also. There should be 4 roots because it's x to the 4th. And as far as the actual zeros go, 4 is a 0, 1/2 is a 0, there's 2 more. And I could keep guessing and checking with other possibilities, but this is only from rational zeros. Rational zeros means you can have a fraction with a numerator and a denominator that are both integers. It won't give us any square roots, it won't give us any imaginary numbers. And really the good news here is this red equation that we have simplified down came from 2x to the 4th, 2x to the 3rd, now it's 2x squared. So this red equation is 2x squared plus 0x minus 20. And I want to know what's a 0, so I'm going to make it equal to 0. I'm not good with solving quartics or cubics, but once it's x squared, I have a lot of strategies. And for this one, I'd just add 20 to both sides, divide both sides by 2, then take the square root of both sides, and I get x equals plus or minus square root of 10. And those are the 3rd and 4th zeros for this one. These are always going to go in pairs. If there's a positive root 10, there's got to be a negative root 10. So these are our 4 solutions to this one. Of this one, and I could list all of the possible ones, the factors of 2 divided by the factors of 10. And I don't really want to do a ton of guessing and checking. So what I'm going to do is go to my calculator, enter in this equation. Remember, it is 10x cubed. So there it is. And if I go to the table, I'm looking for places where x is something and then the y value is 0. And I can see from this that when x is 2, y is 0. So there's a quick way to find a solution. That's kind of nice, that avoids some of the guess and check. And even better than that, I'll go back to my notes again. I could have any of the factors of 10 be in the denominator. So we could have 1 over 10, we could have 1 over 5, we could have 1 over 2. We have a lot of possibilities. So if I go back to my calculator, I can make the x values that are fractions actually show up. So I know, again, one answer is 2. I can see that from here. So there is a root of 2. And then if I go to second window, which is the table set, we're going to have the table start at 0, always started at 0. And then the delta table is what the x values change by. And because we could have a denominator of 2, I'm going to put delta table 1 divided by 2, or 1/2. And what that does for us is once we go back to the table, notice how the x values now change by a half. We have 0, 1/2, 1, 1.5, 2, 2.5. So I have all of these, and I'm not exactly sure where there's another one, but if I scroll around, I see at -0.5, there's another one. I know my fractions, -0.5 is -1/2. So another root is -1/2. I didn't really have to do any work to find it. I just used the technology and what I know from the rational roots theorem. There should be 3 solutions, and I've got 2 of them. I'll go back to my calculator, look at the graph, and I want to see, where does this graph cross the x-axis? This one is x equals 2. I just got -0.5, so it looks like there's another slightly positive one in here. To find that, I'll go back to window, go back to table set. I'll have my table start at 0 again, and the delta table, remember, this is what the x value changes by. I set this equal to 1/2 because 2 was one of the factors of 10. I could also put this as either 1/5 or even 1/10. I'll go for 1/10 because that'll account for the 2 and the 5. Now I'll go back to my table. I'm looking on the table at 0.2, at x equals 0.2, there's a y value of 0. So 0.2 is 2/10. I have these all changed by 1/10, so 1/10, 2/10, and so forth. So at 2/10, there is another solution. 2/10 simplifies to 1/5. And look at that, I have all 3 roots, and I didn't have to do a whole lot of work for it. If I don't want to go that way, I can. To answer the question, though, the x-intercepts are 2, 0, -1/2 0, and 1/5 0. So in the context of this question, I want to make sure I put my answer as x-intercepts and not just roots. So that process can go a little bit faster if we're using our calculators. And so at this point, I'd encourage you to pause the video, enter this equation into your graphing calculator, and see if you can find some of those zeros without having to do all of the synthetic division. We're expecting a total of 5. See if you can get all 5 of them from the calculator, great, a lot of time saved. If you can even get 3 of them and then use synthetic division to simplify it down, you've helped yourself out also. This next example, we're trying to find the zeros for f of x given this quintic x to the 5th. And I know that the possible rational zeros are factors of 10 divided by factors of 6. I'm going to use that to my advantage and go to the graphing calculator, enter in y equals this. There's my equation. If I go to second table set, I have the table start at 0, always start at 0, and then delta table is, I did 1 divided by 6, and it gave me this repeating decimal, but that's 1/6. And if I go to the graph, I can start to see where I'm expecting to see answers. There's a -1, a slightly negative, a positive, and a positive. So I have 4 different ones to look at. It looks like the most negative is around -2. So if I go to the table now, I'll scroll back to around -2, which is where I think I saw one of them. I'm following along on those y values. As soon as I see one that's 0, aha, I got an answer. There's at -2. So there's a 0. There's a 0 at -2. Instead of using guess and check with the synthetic division, I can use this instead. And if I look on my screen, I see another one right here. -0.3 repeating, that would be -1/3 as another 0. I'll write that one down. I'm continuing to look at my y column and looking for a 0. So there's another one at 0.5. So I'll write both of those down. -1/3. Positive 0.5. So there's 3 out of the 5 solutions. And I'll look on the graph again and trying to figure out if there is another one in here. Not exactly sure. So I'll go back to the graph again. And it looks like there's some more that are packed in here that aren't showing up on the graph for me. The good news is I have 3 solutions out of 5. Here's why I am going to go back to using synthetic division again. 6x to the fifth, 11x to the fourth, minus 33x cubed, minus 57x squared, plus 15x plus 10. Because -2 is a solution, it should give us a 0 at the end, and it should, more importantly, simplify down the original. I'll start going through this process. All right, so -2 worked. Then I'll try -1/3. It should work also, but it's going to, most importantly, simplify this down. If you're good with arithmetic, you can start doing these kind of quick. So -1/3 verified that it works. Lastly, 0.5 or 1/2. That one worked also. So what I'm left with down here is 6, 0, -30. It's not x to the fifth, x to the fourth, x to the third. It's 6x to the second minus 30 equals 0. Add 30 to both sides, divide by 6, take the square root, and my final two answers then are positive and negative square root of 5. 1, 2, 3, 4, 5 solutions, and that's what I was expecting. One last problem here, and here it is. So what I would do for this one is enter it into my graphing calculator to begin with. There should be a plus 2x at the end. Sorry about that. Put a 2x there. Enter it into my graphing calculator to begin with. And because we have a 1/6 out front, I'd want to set my delta table to 1/6. Look on the graphing calculator to find the solution. So I'll help you out a little bit with that one. One of the ones you should see is at 0. So if we then simplify this down, plus 2x plus 0 at the end, simplified it down. And then I want to keep looking through there, get on my calculator, set delta table to 1/6, and I would see that there is a 0 at 2/3. I'll just go ahead and tell you that. Then if we simplify this down, there's 6, 9, gets us down to this, which isn't x to the fourth, x to the third, it's x to the second. So it's 6x to the second plus 9x minus 3 equals 0. A couple of things about this. First of all, it's an equation, so I can divide everything by 3 to get smaller numbers. I like this red better than the green, smaller numbers, and then try to factor it. Thing is, this one doesn't factor, but we do have quadratic formula. So we can say x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2a. I know I'm going quickly here. This is a lot of arithmetic. If I find the discriminant, what's on the inside, that ends up being 17. Here is our final two solutions. We have this. So answer the question, product of linear factors, we'd have x minus 0, just x minus 2/3, I could rewrite as 3x minus 2, it would be the same thing. And then, x minus -3 plus the square root of 17 over 4, that looks disgusting. X minus -3 minus the square root of 17 over 4. But because it says a product of linear factors, I'm going to make it look like that.